Are there any questions so far? Okay. Good. All right, so that's some examples. Here are some others. Here we have a polynomial as well. We have one of degree 3, right? The biggest exponent of x here, as you can see, is 3. This is the leading term. That's where the biggest exponent of x is. So the leading coefficient would, the leading term is minus 5x cubed. The leading coefficient would be minus 5. And the constant term is not there, right? You know, it's not written, so it's understood to be 0. Here's another one. Right, here's a polynomial. Now we have a bunch of monomials added together. This is a polynomial of degree 5, right? The term with the largest exponent of x, that's a 5. That's this term, x to the 5th, so it's the leading term. Leading coefficient's 1, and the constant term is 12. Okay. Any monomial is also a polynomial technically. You know, a monomial, you know, it's just a polynomial with only one term. So 5 alone is technically a polynomial. I mean, it's a polynomial of degree 0. In this case, the leading term would be 5, and the constant term would also be 5. And there's really nothing special about 5 here. You know, it could be any non-zero constant. If you had 0, though, you know, instead of 5 here, if you had 0, that's a polynomial. It just doesn't have a degree. You know, the degree is not defined. Okay, that's what polynomials, you know, those are just some examples. Now, just like with monomials, we can add and subtract polynomials. And how do we do that? It's just combining like terms, just like with monomials. We just combine like terms. And I put 2 methods here to accomplish that. We have the horizontal method and the vertical method. I mean, they're both based on the same idea. You find like terms and you combine them. The vertical method, at least to me, is more visual. I personally like it better. But if you want to use the horizontal method, that's fine. You know, it's up to you. I just like to present more than one method when I can to address different learning styles. Because I know everyone learns differently. So basically, both methods are best demonstrated by example. So what I'm going to do now is demonstrate it. So for the horizontal method, again, it really just boils down to finding like terms and combining them. Okay, so let's add this polynomial to this one. I mean, this step here is probably unnecessary. I put them in parentheses. Okay. But again, we want to determine what terms are like terms. Okay, so we have 7x squared here. See if I can draw the circle. There we go. So we want to know, are there any other x squared terms? None in here. No. No. Oh, here we go. And again, you don't forget the minus sign. You have to keep it together. You have to keep the minus sign with it. When you combine them, you're going to have this, 7x squared minus 5x squared. All right. Next, we have 3x. As you can see. Now, are there any x terms here? Well, we have a 1, no. We have x to the 4th. Can't combine it with that. X cubed, no. This is already taken care of. Up, minus 3x. See if I can draw this. There we go. Okay. So we have 3x and minus 3x, right? We can combine those, as you can see. Okay. So now we combine those. What's left is 1. I'm putting a lot of marks in here to make it easier to see. I hope it's working. So, well, we want to combine 1. What can we combine it with? X to the 4? No, not x cubed. These are taken. 5, we can do that. So we can combine to get this. After doing that, what's left over is x to the 4 and x cubed, so we put them here. Okay, now we're ready to combine like terms. So we have 7x squared minus 5x squared. Okay, let me change. 7x squared minus 5x squared, that's going to become 2x squared. Okay, so that's what we get here. 3x minus 3x, that becomes 0. 1 plus 5 becomes 6. X to the 4 stays as itself. There's nothing we can combine it with. X cubed also stays as itself. Now we get this, 2x squared plus 6 plus x to the 4 plus x cubed. That's what we get here. Now I rewrote it down here. You know, also the 0, again, we don't have to write that. It's good to write your answers in standard form, where again, that means the exponents of the variable, or in this case, x, they're decreasing as you go from left to right, and the constant term is last. So that's what I did from here to here. You know, it's really good to write it in standard form. Okay. Any questions on this? Okay. Let's do another one then. So we're going to add these two polynomials together. Again, I use parentheses here. I mean, I don't really think that's necessary. So, but we do have to find like terms, and then we combine them. So here, let's see. We have 12x to the 5th. What can we combine that with? Well, nothing here. 6x to the 5th. So we combine that. That's how we get this. Next is 4x to the 4, right? Can we combine that with anything? Well, nothing in this polynomial. Remember, you can only combine it with like terms. Okay? You can only combine it with like terms. Here we go. Couldn't find the mouse for a second. So we have that. We can combine it with, negative 3x to the 4. Remember, you want to keep the negative with the term. You know, that's what you want to do. And so we get this. Okay. Next, we have minus x cubed. Can we combine that with anything? See, no, that's an x squared. That's a constant. These terms are taken care of. No, that's an x squared minus 10. We can't combine it with anything, so we're just going to leave it alone. 9x squared, let's see. Can we combine that? Well, we can't combine it with 1. These are handled already. X squared, right? The whole point is we're looking for like terms to combine. Sometimes, like with minus x cubed, you may not be able to combine it with anything. That's okay. So we have 9x squared with, oh boy, come on, x squared. Now, finally, we have 1. Can we combine that with anything? Well, the only thing left is minus 10, and we can combine it. We get 1 minus 10. All together, we get this. Let me 12x to the 5th plus 6x to the 5th is 18x to the 5th. Right? You know, again, we just add coefficients together. 4x to the 4 minus 3x to the 4. That's x to the 4. Minus x cubed, that's, again, we just leave it alone. We can't combine it with anything. 9x squared plus x squared, we get 10x squared. 1 minus 10 is minus 9, so this is our answer. Notice it's already in standard form, right? The exponents of x are decreasing as we go from left to right. Okay. So it's in standard form. Any questions on this?